then now we can going to continue our first topic today, F#.
Everyone. So today I'll be giving you an introduction to F#, basics to functional programming. So this talk is for beginners only. So if you already know what a monad is, or if you have some basic introduction to functional programming before, you may find this talk a little bit easy, but bear with me. So about me, I graduated with degrees in mathematics, like for my bachelor's and master's, so I really like functional programming, which explains why I like functional programming. I'm currently working as a financial engineer at Numerical Technologies. And what is functional programming? I tried to distill down like the most core concept of functional programming. It is based on combinatorial logic, and you use functions to solve problems. Of course, there are other good properties of functional programming like purity, type check, etc. But I want to focus on the function part, just for this talk today. And some of the functional languages, like some of the ancestors are like ML or Haskell, but it has a lot of descendants and cousins, which today I'll be focusing on F# because it's on the .NET. Some people also say that libs and some of their dialects are also functional languages, but I'll put it aside for now. So who uses functional programming? So for example, Standard Chartered uses Haskell, Walmart and Jet, they use Clojure, Jane Street is a big trading firm, they use OCaml, and LinkedIn and Twitter, they use Scala. But I'm not so sure how big is that Scala right now. So just to let you know that there are a lot of companies out there that uses functional programming. And why learn functional programming? Because you can write your code very concisely. You are able to write more stuff with less words. So you're able to write things concisely, and you're able to reason about your code. And with a better vocabulary, it helps you unlock more difficult programming problems. And worst comes to worst, there's always better salary, because it's a little bit hard to find functional programmers out there. And if you have any questions, feel free to just raise your hand and I'll answer your question. So this talk will be focusing on F#, but there are Scala, Haskell, Clojure, and Elm meetups all like in Singapore. So if you're interested in any of these other functional languages, feel free to go and check them out. So if you're using, I'm assuming that most of you use C#, right? So if you're using C#, should you be using F#? If you're eager to learn, then of course, yes. Because it's fun, it's easy to learn, and once you learn F#, you're able to access the other functional languages like Haskell or maybe Scala and other stuff. It's easy to transition from one functional language to another. And it helps you to change the way you think and how you do program. And also you can directly call F# directly from C#, which is a huge plus. If you're already programming in C#, it's like a more tool set for you. If you are skeptical, I would still say yes, it's worthwhile to learn F# because a lot of new features in C# does come from F#. And F# has a better syntax for you to learn these new concepts that C# is slowly adapting. So eventually you will learn functional programming like one way or another. So why not just start with F#? So the core concept of functional programming, at least I try to distill down the two, is functions are things. The analogy I would like to use is like a coffee machine. I'll explain the analogy later. And you can compose functions. The analogy is this toy train with the wooden track underneath the train. So here are the two analogies. Functions are things, and you can compose functions. So what is a function? A function can be think of as a machine that takes an input and returns an output. It takes an input and returns an output. So let's look at an example. So a coffee machine takes coffee beans and returns coffee the drink. So the coffee machine takes an input, returns an output. and some mathematical functions. Let's say that f is a machine that takes a number x and returns x plus 5. So if you throw in the number 10, it gives you 50. So far so good, right? If I throw in 20, it gives you 35. So in F#, you will write something like this. This is actual F# code, that fx equals to x plus 5. This thing compounds in F#. And then to call the function, you just write f30, which will give you 35, f100 gives you 105. A slight difference, you don't need brackets. A little bit different from like mathematics or in C# notation, you don't need the bracket. In math, you write something like that. In F#, you don't need the brackets. So far, so good. Then to use the function, again, you don't need the brackets. In mathematics or maybe in C#, you need the brackets to call the function, but in F#, you don't need it. So example, so let fx equals to x attached with a hello in front of it. So I take a string x and then I attach hello in front of any input. The diagram will look like this. Easy enough. Let's try another example. Let's say that I take a string x and I return how long is the string. So for example, hello gives me 5, computer gives me 8. So the diagram will probably look like this. Let's look at another example. So let xs be a list of numbers and I sum them up. So I take a list of integers and I return a sum, the integer. The diagram will look like this. I take in a list of stuff and I return one output, which is a sum, a number. So if you have multiple inputs, then I will write that fxy equals to x plus y, where I have two inputs, x and y, both are integers, and I return an integer. Notice a slight difference that you don't need brackets, you do not need commas. In C# you probably need commas or like brackets, but in F# you don't need it. So in math you probably write something like that, but in F# you'll write like that without the brackets and without the commas.
What is the different thing?
What's the different thing?
The first thing you write is partition product.
Yes.
The second time you have a function that produces a function.
Technically yes, I will get to that later, yes.
I mean, it's the first thing that is syntax and it's hard.
Yes. Yes. Technically speaking, the first one is a valid syntax in F#, but it gives you something completely different. But I want to ignore that. Okay. Because in mathematics, at least I would write something like that. But I just want to, just like you said, I just want to get rid of all the brackets and commas because I want to avoid the condition problem. And then to use it, you don't need to use the bracket, you don't need to use the comma. And if you have multiple inputs, you write fxyz equals to something like that. And if you have multiple inputs, let's say a, b, c, d, then you write something like that. Where if you look at the type signature, like this function takes in a, b, c, d, and returns an output. So rather good. And function composition. Two functions can be connected together if the output of the first function is the input to the second function. Here I want to draw the analogy to the toy train tracks, where you can connect the train tracks together if like the first one fits to the second one. So let's take a look at this. You have a machine that takes an apple, returns a banana. You have a second machine, takes a banana, returns a strawberry. And the first output is the second input. And so you can put them closer together, and then you can put them even closer together, and it is effectively a bigger machine. You combine the two machines together, and it gives you a bigger machine. Effectively, the banana is hidden. You don't need to know what's going on in the middle. You can say that it's composed of little tiny functions, and you get an even bigger function. So if you have a coffee machine that produces coffee bean and produces coffee, and then you have a programmer that takes coffee and then produces software code, these two can be combined together, and effectively you have a bigger machine that takes coffee bean and returns software code. You don't need to know what's going on in the middle. Like there may be some coffee machine in there, there may be some sad programmer in there, but it's a bigger machine that takes coffee bean and returns software code.
So if we have a function f that takes A to B, and we have another function G that takes B to C, then you can connect these two functions together by writing G f of A. Let's take a look at an example. If let's say you have a function f that takes a list of exam scores and calculate the total sum, the total scores of those exams, and you have another function G that takes that total score and gives you your letter grade A, B, or C. These two functions f and g can be connected together, and in a diagram it will look like this. You have a list of exam scores. It goes through the function f to calculate the total score, and then the total score goes through another function g that gives you the letter grade A, B, or C. Then you can connect these two functions together as such: G, F of 20, 20, 50 in this slide, for example. One thing we need to note is that the types must match. For example, here, if F takes A to B and G takes C to D, and if you try to connect F and G together, you'll have a compilation error. You'll have an error. The output of F is not accepted by G.
So that's why you're saying that you can forgo all this bracket, right? But why? Yeah.
Yes, this one I purposely put the bracket to show you the conventional way of doing composition.
Before the slide, the one.
For the slide, this one.
Yeah. You see, you still put bracket.
The square bracket is for the list of numbers. It's for the list. The curly bracket is there to use the function. I just want to make things a tiny bit clearer.
Well, can you know it, right?
Yes,
sir.
So square bracket parenthesis here is because F# is left associative. So if you write G of F without square bracket, it will try to apply G to F and then apply second function to result of what you get of this G to F application. Here we can break this rule, and we first have to evaluate what's within bracket.
But just now you saying you can ignore the bracket.
No, you cannot. It will change the semantic because
for this you can't ignore the bracket.
In this one, there's three things: G, F, and the list of numbers.
Yes.
If you remove the bracket, it is as if you're applying G that means two things. It's completely different meaning. Yes.
Okay.
Yeah. And so I want to get to the most important thing in F# is the pipe forward operator. This symbol, vertical line with a angle. This is a very important operator, the pipe forward operator, a key idea in F#. Why is this operator important? This operator allows you to change the order of the function and the input. This allows you to change the order of the function and the input. So let's take a look at an example. Fx equal to x plus 5. To use the function, you normally write f of 100. You tell me what's the function, then you tell me what's the input. Now instead, you can say 100 pipe forward into this function f. You tell me what is your input and where do you want to apply it to. So it allows you to change the order. How is this useful? Is that if let's say you have two functions that can be connected together, you can write conventionally GFA, like with the bracket, or you can completely write it in reverse like this. A pipe to F, pipe to G. Usually, we prefer to write it in multi-lines like this. We write it in multiple lines. And the reason of writing like this is that the angle, that symbol can be interpreted as a then do. You can interpret it as a then do. You start with A, then you do F, then you do G. Why is this helpful? Is that you start with X, you pipe it to F, you pipe it to G. You can interpret it as you start with X, you apply to F, you apply the result from F to G. You can apply like this. And maybe you're not satisfied. Maybe like the toy train track, you want to connect more tracks, you want the train to go further, you want to connect more tracks, you want to connect more tracks. I add one more statement. That I'm not yet done. I apply what the previous result to H. Maybe I'm not yet done. I go one more step. All of these, the code on top will compile and it will be interpreted like that. You can connect and connect and connect. You can go as far as possible. Just connect and connect. That's the analogy. as long as the first output is the second input, the second output is the third input, etc. As long as the condition holds, then you can connect and connect as much as you can. In C#, you can probably write something like this if you define the then operator. It is a little bit not so natural to C#, but you can definitely do it. A little bit not so natural, but you can do it in C#. So the benefit is that you can express your logic step by step. It's like step 1, step 2, step 3. It's quite logical, and it's easier to read for the lame, like the normal people. So I'm going to try some Project Euler questions. Have you guys heard of this Project Euler website? It's some programming website with a bunch of like math programming problems. So I'm going to try some problem from this website. So, question 1, find the sum of all multiples of 3 or multiples of 5 from 1 to 999. How would I solve this problem in F#? I would do something like this. I'll give you like maybe 10 or 20 seconds to take a look at it, and then I'll show you the interpretation. The interpretation would be like this. And you can see a line-by-line comparison. From 1 to 999, then you do some filtering, like a water filter. Then you sum up the remaining numbers that you have kept. So you can see a line-by-line comparison. Of course, you can already do this in C#. That's link Q. You can already do this in C#. It's link Q. But effectively, it's the same thing. Let's take a look at another. So is this okay?
So the question,
fun means function. Fun is a keyword that represents a function, like a lambda expression. It's a function that takes x and return x divided by 3 is equal to 0, etc., etc. Fun is a keyword. Is this okay?
What the percentage?
The percentage means x divided by 3 gives you a remainder of 0, which means x is divisible by 3. Any questions? Yeah. So, the diagram would look like this. You start off with the first list. You go through the first machine so that you have the middle step that contains like the remaining numbers. And then you go through a second machine that sums up everything. That's where the connecting comes in. Any question? Okay. So let's take a look at the question 6, a little bit modified. Calculate 1 square plus 2 square until 100 square. The code would look like this in F#. The English interpretation would look like this. From 1 to 100, you individually square each number, and then you sum up. Of course, you can already do this in C# link Q. It is the select. And the diagram would look like this. You start off with the first list, you individually convert each element, and then you sum them up. Like the converting part and the summing up is like two different functions. Any questions? So if let's say I want to sum up these squares of prime numbers, then maybe I'll do something like this. From 1 to 100, I take out the prime numbers, like the second line, I take out the prime numbers, I filter out the prime numbers, then I square each individual prime numbers, which is the third step, and then I sum them up. Of course, I need to self-define this is prime function, but you can certainly, once you define it, it's very simple, like 4 lines, like step 1, step 2, step 3, step 4. You can almost translate it like line by line into English. Any question?
Sorry. Why? So this filter looks weird.
This
So
filter.
Yeah.
Oh yeah.
List filter is prime is enough, and fun x to is prime of x is just noise.
Yeah.
Maybe we should just step into the presentation because I think this is for beginners, and I think it's probably if we skip curry and if we skip point implementation, I think it will be easier for the beginners every time it's done.
Yeah, but we started with a function being like first class citizens, And this is a perfect example where you can show that like function itself can be passed around. You don't need to construct this dump. You can use is prime for filtering.
Yeah, but then he has to explain configuration, which is going to be a little bit harder.
I'll be able to get to the point-free notation, like something similar maybe at the end of the talk. But thanks for the suggestion. Thanks for the suggestion. Thanks. So an example. So like, if let's say you have because I'm working like in probability theory. So let's say you have 3 events occurring with a probability of 0.2, 0.3, and 0.4. The probability of no event happening, which all 3 events not happening, would be that 1 minus 0.2, 1 minus 0.3, 1 minus 0.4. And so the probability of at least one event happening will be 1 minus the previous result. So this is like a very basic like math or statistic calculation. In general, if let's say you have P1, P2 until Pn, we have like a list of numbers, then that's the probability of no event happening, that's the probability of one event happening, like the same formula. We have a list of numbers. How do you write down the calculation that calculates this? In F#, I'll probably write something like this. You start with a list of numbers. You convert each number to 1 minus Pn, 1 minus Pi. Then I calculate the product. I just multiply all of them together. And then I do 1 minus the final result. Of course, I need to define list of product, but I can do it. And then that will be something that I'll do in F#. We can do something similar in C# as well. Something like this. You use link queue. You need to self-define the product. You need to self-define the then. But you are able to define like one number like in one go instead of like breaking into intermediate steps or something like that. Is everything okay so far? Okay, and now I'm going to talk about partial application, and which is a very useful language design. So if let's say I have a function that takes 4 numbers and I add them up. So right now I apply all for 1, 2, 3, 4. I expect the result to be 10. What if I forgot one variable? This thing has 4 inputs, but I only provided with 3 inputs. Will this compile? Yeah, it does. And it does compile, and it gives you an integer to integer. So the analogy is this: if you have a machine or a function that needs 5 inputs, you only provide it with 2, then it still needs 3 additional inputs. Put it in another way: if you have you need 5 inputs for your function, you only provide it with 2. We are producing a brand new machine, a brand new function that still needs 3 inputs. So if I write f of u, v, w, x, y, but I only provide it u, v, then I produce something that still needs 3 inputs. In C#, if you write something like this, it will fail. Like it will have a compile error.
So that means in F# they're still able to compile. There's no error.
For this specific case, it has no error because I provided with 2 inputs. It still needs 3 inputs, so this result thing still needs 3 inputs. It is a function.
Could it be like F, U, W?
No, cannot, because I expect the second one to be V.
Oh.
If you give me W first before V, it will have a compile error. So for example, in C#, I need 2 inputs, but I only provide with 1, then there's a compile error. So example, let's say that I have like some data points, and I want to find the linear interpolation, which means if I give you an x0, I draw a line vertical on top, and I hit like one of the straight lines, and I calculate what is y. So this is a process that depends on the x0 point, and it also depends on the data point, this blue colored data point. If I provide it with a different set of data point, for example, this yellow points, it gives me a completely different y0, even though my x0 is the same. So this is a function that depends on the data set provided and the x0 provided. If I provide only the data set but without x0, so for example, let's say I have data set 1, data set 2. I provide it into the interpolation function. Now I have f and g. This f and g still needs x0. The interpolation needs two things, but I only provided the data set. So this f and g, both of them, takes x0 and returns a y0. But the tricky thing is that the y0 provided, like there's a hidden dependency that depends on the data set that is already baked into the function f and g. So that's how. So effectively, you can use f and g in some of your future functions, etc., etc. But there are some hidden dependency that's baked into f and g, and it makes things easier to write once you have partial application. And some say that partial application is sort of the equivalent of dependency injection in C#. Like some people tend to say that. I want to elaborate more. So the special case that if you have n, if your function needs n input, but you only provide it with n minus 1, then you still need one more input. So effectively, you produce a one input, one output function.
Let's take a look at this picture. Assume that we have this function f that takes in a, b, c, and x. It takes in a, b, c, and x, and it returns the output y.
If I put in the inputs a, b, c right here, I put in the a, b, c right here to my input, and then I squint my eyes a little bit, I make the picture a little bit blurrier, effectively it looks like this. Effectively, I block out all the holes, and it is an x to y function. Why is this useful? Is that I assemble everything. Let's say that I have a function like that on the top, and I provide it with almost everything except the last input. So effectively, it is an x to y function. Maybe I have a second function like that, that after I provide with everything except the last input, it is a y to z function. So now I can connect them together. It's x to y, y to z. I can connect them together. So notice that each of these is that I assemble almost everything except the final component, so that I can start connecting them together, So here are some of the example codes that I showed you just now. Notice that this involves assemble almost everything. Like inside there, I have a filter function and another function inside it. That thing is like I assemble everything so that I can connect them together. I assemble almost everything and I can connect them together. And this special case, you can already do it in C#. It's called the C# extension method. It's the this keyword in C#. So if let's say I have the function fgh, where part of the output of f is part of the input of g, the output of g is the part of input of h, then using the this keyword, I can connect them together in C#, something like this. So you can use the C# this extension keyword to do this kind of piping operation, like you connect and you connect. And effectively when you compile it out, it looks a little bit ugly. It's a very good syntactic sugar for you to do the connecting in C#. It's a good syntactic sugar. And more importantly, the general case is just for fun. So just now I mentioned that if you have a function that takes in 4 inputs and returns 1 output, in C#, if you try to partially apply this, all of these will have a compile error. It will fail. In C#, this will fail. In F#, it will not. So that's the type signature fun function ABCDZ. The second one, the function ABCDZ, is not flexible because you need to assemble everything before you can start calling this function. So this is not really a flexible signature, like type signature. The first type signature is more flexible. Why is that flexible? Is that this signature, if you provide it with A, I still get the red stuff. I provide it with A, I still get the red stuff. I provide it with AB, I still get the orange stuff. I provide it with ABC, I get the white stuff right there. So this type signature is more flexible because you can partially apply. You can just give me part of the thing. You don't need to give me every single input, and it will still compile. So with some like helper function, which is the currying function, you can write this helper function in C#, and then you can take your original function f, and then you can convert it into a special version of this function f, which I call it g, and now GA, GAB, GABC, all of these compiles. I mean, whether this is like, very useful to your, source code or not could be like questionable, but I think this is like kind of fun-ish. Like, you take a function f that you need to assemble everything. Now I can just assemble part of it and it compiles. It's kind of fun, I guess. Any questions? And now let me get to higher order functions, which is functions as inputs. So the typical functions that we write, usually at least on a lower level, we'll take in like primitive types like double, integer, strings. We take in like these very basic inputs. But you can start taking functions itself as inputs. You can have a function that takes in another function. You can also have a function that returns another function. The analogy would be like this. Take a look at the left-hand side. The left-hand side is a coffee machine. The coffee machine itself is a machine, is a function. The coffee machine itself is a machine, is a function, but it gets accepted into an even larger machine, an even larger function. In this case, it is the coffee shop. So the coffee shop is a larger machine, a larger function, that takes in a smaller machine, a smaller function, the coffee machine, to produce coffee. So let's take a look at like some of the examples right here. Just now we did like filtering and map, where we filter out the stuff, we convert each individual element. So the filter function, I have a list of x, and I want to determine whether I want to keep it or I want to remove some stuff. How do I remove, how do I keep stuff? I need a function that gives me true or false. I need like a detector function, like x to boolean, the x to boolean function right there. So the filtering function, the C# linkQ.where, the linkQ.where itself is a bigger machine that takes a smaller machine. And then the F# map, which is the linkQ select. This linkQ select, I have a list of x. I want to convert it to a list of y. I want to know how to convert each individual element from x to y. So that thing itself, I need a function that goes from x to y so that I can know how to convert each individual element. This map, or the C# linkQ.select, this itself is a higher order function that takes another function as an input. Is everything okay? Any questions? So let's take a look at an example. Let's say that I'm developing some like insurance product. I want to determine how much I want to charge a customer. So I have a price. Maybe this product depends on integer, like depends on age. Like maybe if I'm getting younger or older, like the price of the insurance product should change. So maybe this function takes in an integer and returns an amount, like $1. Maybe this depends on the probability of injury. Maybe I'm 5% likely to get into a car accident this year. Who knows? So maybe this number should affect like the price of this insurance product. But what if this probability depends on time? So maybe I'm 5% more likely to get into a car injury this year. Maybe I'm 10% likely to get into a car injury next year. So this probability of injury depends on time. So it's like not a constant, it's changing. So you can give it in a function. So this pricing algorithm like takes in an age and takes in a probability function that depends on which day is it, which time is it, and it gives me a double. So this price function takes in another function as an input. Is this okay? So let's take a look at another example. So Newton's method. So you have some function that you want to find the root of this function to. So I have this function, I want to find where is it 0. So this algorithm, this Newton function algorithm, depends on the starting point, which is a floating point, a double number, and it depends on a function, depends on f, depends on the function that you want to solve, and it also depends on the derivative of that function, df. So this Newton method, this Newton function, this Newton algorithm depends on the starting value, and it also depends on a function, and also depends on another function. Technically speaking, the derivative depends on the original function. But anyway, this function, Newton function, itself takes in another function. So this is just like some basic application of functions taking in a function. So that's like some of the most basic tricks in F#. That you should try to chain or connect your computation as much as possible. You connect the train track, you connect the train track, you connect the train track, so you can do a lot of computation in one go. You can also use partial application to get a new function, which in C# you can use this keyword, like the n-1 trick. You can already do this in C#, this. And also you can do higher order function, which means that you can use functions as input and out as inputs to your functions or as output to your functions. Of course, there are a bunch of other properties, like good properties in F# that I don't have time to go through today. So some of the good learning resources that I know about F# is this fsharpforfunandprofit.com. This is a very good website for you to learn F#. I highly recommend it.
And of course, there's this book, Real World Functional Programming, written by Thomas Petricek. This is also a pretty good book because it draws a lot of analogy and comparison between F# and C#, and it allows you to look at the similarities and differences for you to learn a little bit better. Of course, F# has their own official website, fsharp.org, that you can check out for more information. Maybe blog posts and books are not your thing. Maybe you prefer to watch some videos. No problem. You can check out Scott Vulashin. I highly recommend Scott Vulashin.
Started, I recommend Scott Vulashin. He's a very good tech educator. He has a lot of good talks on YouTube, on NDC. If you are interested, you can try to watch some of his talks on YouTube, and it should be pretty interesting. And if you want to get started, there's an F# for Fun and Profit blog. Then you can try out some Project Euler questions. I have some training materials that I use to train my interns. So if you're interested, you can ask me. And here are some sources that which companies have picked. That's the other Python.
Can you share some real life experience from your work where it will be very difficult or impossible to be done in C#?
I know that most of our statistical and mathematics calculation that we do most of those calculations in F#. Of course, it's good for that, but one thing that I noticed about F# and also functional programming is it's helpful for you to help you detect some of the corner cases, in particular null values and missing values. Once you get exposed to F#, you'll start to appreciate dealing with null is kind of bad, dealing with exception is kind of bad depending on your your opinion. I personally believe that exception is kind of bad, right? Gives you the concept of trying to isolate, try to deal with things as soon as possible, which even though quite a number of our source code is in C#, but after going through F#, I started to notice there's this thing wrong and that thing wrong in C#. Even if you don't get to use F# in your work, once you learn F#, you'll start to notice things going wrong in your C# code base, and you'll try to adapt it a little bit towards the F# stuff. I mean, of course, mathematics and statistics calculation is always good in F#, but I want to stress that even non-mathematics or non-statistics calculation or code base could benefit from F#. Any other questions?
does Microsoft have any plans for promoting F# or encouraging programmers to do F#? Because right now it's a wonderful language, but it's extremely unpopular. So it's something like hard to find a job.
I would say that, like, you know, in terms of F#, like most of the jobs are most likely in like either Europe or maybe like in New York City. Like some of those like finance company uses like F#. To be honest, if it like it's also like, you know, part of my regret. I kind of regret that there's not much like F# jobs out there. So probably in terms of a more practical perspective, like, you know, like learning F# is more helpful to, one, like notice like some discrepancy in your C# code. Like you can start using like F# like functional programming techniques in your C# code, or you can call F# functions that, you know, will take forever to write in C# or like you make a lot of errors in C#. You call directly from F#. And the second thing is, you know, transit a little bit better. I'm saying it's like Microsoft Office that, you know, once you learn F#, you are able to transition to other functional programming languages. You know, Standard Chartered is always hiring.
But I guess functional programming still not as widespread as object-oriented. However, in terms of C# and F#, it's good to learn F# because the mix in C#. So I think in certain things like formulas and meaning translate nicer to F#. So it's a very complementary skill. Rather than looking for a job in F#, rather you look for a job in .NET and then you have some skills in F# to complement your C#.
I agree. Like having F# skills, and then, you know, you'll be a much more rounded programmer. That once you hopefully employer should be able to see that, you know, with C# and F# experience, like a good blend of everything.
So is this experience that you when you write C# code and you invoke the F# function, is this experience very smooth, or there is some obstacle?
If you just isolate your code so that you only take in like IEnumerable, like, you know, sequence of numbers, you use IEnumerable, you try to use data structure that is compatible to both C# and F#, then the process will be smooth. So I started experimenting with C# and F#. I noticed that the list data structure is different in C# and F#. Like there are some slight differences that makes things a little bit complicated. So once you isolate your data structure to the common data structure that is used in C# and F#, in particular like IEnumerable, then the programming process should be smooth. Yeah. Is that it?
Thanks, Jake. Thank you.